Welcome my dear learners for this course on engineering graphics. In this module 2 we are discussing on orthographic projection of plane surfaces. So far we have solved 20 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 21 of our discussion states that a hexagonal laminae of sides 25 mm rests on one of its sides on HP. The laminae makes 45 degrees to HP and the side on which it rests makes 30 degree to VP. Draw its projection. So we have an hexagonal laminae of sides 25 mm rests on one of its sides on HP. So that is the first position. In the second position, I should show inclination with respect to HP itself. The laminae itself is making 45 degrees to HP. In the third position, I should show inclination with respect to vertical plane. The side on which it rests makes 30 degree to VP. So the question itself is in order. Come, let us solve problem number 21, for which let me draw XY line first. Let me draw XY line and construct hexagon in the top view. The laminae is resting on HP, so therefore the top view will give us the shape of the laminae. This is X, this is VP and HP for first angle projection. Now I want the laminae to rest on one of its sides, that is on its edges. Now to construct the hexagon, to get edge towards my left hand reference, we are using left hand reference throughout this module 2. So therefore to get side towards my left hand side, first draw a vertical line. For hexagon we will get side on either side or corner on either side. This you people already know. So in order to get sides on either side, first you draw a vertical line equal to its side length, which is 25 mm. Draw a vertical line for 25 mm. Drawn. Next, using this as a radius, construct a circle using compass. Using this as a radius, construct a circle using compass. Once you construct a circle, cut arcs at equal intervals. 1, 2, 3, 4 and finally 5. Now join these arcs to get the required hexagon of 25 mm sides. So join these arcs which is drawn at equal interval to get a required hexagon of 25 mm sides. Done. I got edge on either side. Now give the naming, that is A, B, C, D, E and F. So each side measures 25 mm. This is given in the question. Done. Now take vertical projection and complete the first position front view. So take vertical projections. And draw the front view in the first position. Done. So observer is here in the front view. He can observe A, B, C corners, whereas F, E, D corners are invisible. So therefore I can mark it as A dash, F dash, B dash, E dash, C dash and D dash. Now in the second position, he says that laminae itself is inclined at an angle of 45 degrees to HP. So therefore mark 45 degrees. Mark 45 degrees. Done. Now transfer the lamina. So measure the length of the lamina in the front view. And transfer it. At an angle of 45 degrees, transfer the lamina. Done. Now mark the corners. This is A dash, F dash, B dash, E dash. This is C dash, D dash. Now take vertical and horizontal projection and complete the second position top view, that is Draw vertical and horizontal projections. We have E till here, so draw E, and we have F and D till here, and we have A and C till here, A and C, and finally we have corner B. We have corner B, so that is, this is E, this is A, B, C, D and F. Now join these corners with dark line to get the second position top view. Done. So this angle is given in the question, which is 45 degrees. Now he says that the side on which it rests is inclined to vertical plane at an angle of 30 degrees. It is resting on side AF, which can be seen here. The lamina is resting on the side AF. So AF should be inclined at an angle of 30 degrees to VP. So draw a line at an angle of 30 degrees. So draw a reference line at an angle of 30 degrees. So if I place on this, it will be entering VP. So therefore let me offset it and then draw, to avoid the inclination, or to avoid that certain portion of this is entering to vertical plane. Let me offset it by some distance. So this is useful when we draw orthographic projection of solids. So if I draw 30 degree line and place this lamina here, then DC will enter vertical plane. That is wrong. So therefore I am offsetting the reference line XY. So drawing a parallel line for XY line. Done. So these two lines are parallel to each other. Now for this line, I will take a reference of 30 degrees. Take a reference of 30 degrees. Done. So I have taken a reference line at 30 degrees. You can observe that the resting edge is retaining its original dimension of 25 mm throughout the problem. Initially it is 25. Now also it is 25, no problem. So now FA should come on this line 30 degrees. Draw FA on this line. So I will take F here. FA is measuring 25 mm. So transfer FA. Done. So I got F and A. Now DC is parallel to FA and FD and AC are perpendicular to FA. So first you transfer FD and AC, which are perpendicular. So transfer them. Transferring the perpendiculars. That is FD and AC transferred. So therefore I got, so what I got C and D. I got corner C and D. Now using compass I can locate corner B and E. So use compass, cut arc, Now measure CB and cut this previously drawn arc. So that will locate B for us. So repeat the same procedure to get E. So draw an arc, cut this arc from F. Now we got all the corners, connect all the corners. This completes the final position, top view. Now we have transferred A, B, C, D, E. Done. So you have taken this and paste it here, inclined an angle of 30 degrees to VP, the resting edge is FA. Now take vertical and horizontal projection and complete the problem. So we have E is still here. So I'll get E dash. This is E dash. Next we have F. Next we have F. Next we have D. Next we have D. We have D. Then we have A. Then we have A. Then C. Then we have C. So this is C. And finally B. Finally B. So this is our XY reference. Now connect these corners. F A is the resting edge, then A to B, A to B, B to C, C to D, C to D, and D to E. So we have, this is F, A, B, C, D and E. A, B, C, D, E. Correct? Yes. So this is the required solution for the problem number 21. Let me pause this video for a while so that you people can copy it down. Later we will address problem number 22. Now moving ahead, the problem number 22 states that a regular hexagonal lamina of side 25 mm is lying in such a way that one of its corners on HP, while the corner opposite to the corner on which it rests is on VP. If the lamina makes 60 degree to HP, draw the projections of the lamina. We have a 25 mm side regular hexagonal lamina resting on one of its corners on horizontal plane. The corner opposite to the corner on which it rests touches vertical plane and lamina makes 60 degrees to HP. So since the lamina is resting on HP on one of its corners, let us draw hexagon such a way that I will get corner towards my left hand side. So since it is a hexagon, I will get corner on either side, correct? So first let me draw XY line. First let us draw XY line. Drawn. Let us take this as reference HP and VP. Since I want corner towards my left hand side, first draw an horizontal reference to get corner on either side. To construct an hexagon, draw a horizontal reference line of length is equal to the edge length, that is 50, which is equal to 25 millimeters drawn. Taking this as a reference, construct a circle of radius equal to 25, diameter equal to 50. Done. Now cut arcs at equal intervals. So cutting arcs at equal intervals, I'll get hexagon with corner on either side. Now connect these arcs, you'll get the required hexagon with corner on either side. So this completes the required hexagon. With corner on either side, let us mark it A, B, C, D, E and F. Each side measures 25 millimeters. Each side measures 25 millimeters given in the question. Now take vertical projection and complete the front view in the first position. So the length of the front view is 50 mm, which is nothing but the diameter of this outer circle which is used to construct the hexagon. Done. Now mark the corners. This is A dash, here we have B dash, F dash, C dash, E dash, finally D dash. The lamina itself is inclined an angle of 60 degrees to HP. So mark 60 degrees. Mark 60 degrees and transfer the lamina. Transfer the lamina. Transferred. Done. So we have A dash, B dash, F dash, C dash, E dash and we have D dash. So the inclination of lamina is given, which is 60 degrees. Correct. Now take vertical and horizontal projection and complete the second position top view. So I am drawing vertical and horizontal projection to complete the second position top view. Take it from D also. And now take horizontal projections. We'll get this is still D and we have B and C. We have B and C. Done. Now connect these corners to get the second position top view. Connecting these corners, I'll get second position top view. So this is A, B, C, D, E and F. It is resting on corner A. So corner opposite to the corner is D should touch VP. So D should touch VP. So therefore first let me consider DA and draw DA. First I'll draw DA. DA is measured and transferred. Done. So this is D and this is A. I got corner DA. Now measure these two perpendicular lines to DA. So I mark the perpendicular lines to DA. Where they are passing, and this EC and FB are perpendicular to AD. So measure their length. and transfer them. Measure their length and transfer them. Done. Here also we have transfer it. Done. So what I had drawn is that first I had drawn DA and measured these lengths, marked, and measured these lengths and transferred. So this is F, sorry, A is at the bottom, right? This is F, this is B, C and E. So connect these corners. We have D to E, E to F, F to A to B, B to C and C to D. Done. I have taken this and placed such a way that corner opposite to the corner on which it is resting is touching vertical plane. Now take vertical and horizontal projection and complete the sketch. That is final position front view. So E and F, E is still here. So we have F and E. Done. So D is at the peak. We have D. Done. Now we have B and C. So B and C are till here. So drawn, marked corner C and this is corner B. Also mark XY line. Now connect these corners. We have A to B, B to C, C to D, D to E, E to F and F to again A. So A dash, B dash, C dash, D dash, E dash and F dash. So this is the solution for problem number 22. So this is how we should solve when he gives that corner opposite to the corner touches VP. He can also states that the lamina rests on one of its edges, edge opposite the resting edge touches VP. So in such cases I should draw it by taking edge on either side, repeat the same procedure in the second position, edge opposite the resting edge should touch VP. So like that also you can frame the question. So this is the solution for problem number 22. That's all from this lecture. Thank you all.